Good afternoon once again. No? I'm not sure if Dagler is online already. Let me check. Yes, it's online. No? So last meeting we were discussing the uh, history, the initial history of computing. Okay, dito yan. And then we described a very important event. Okay, in the early history where a very important device considered to be the very first computer was invented, which which happened in Great Britain, no, during 1837, so the 19th century, by a very popular inventor mathematician named uh, Charles Babbage. Okay. He had an earlier invention which is called the differential engine. It's not a computer. It's not considered to be a computer. So Dagler is still slow. So wala tayong magawa, no? But I think we have to make use. There's the sample program. We know that the analytical engine invented by Charles Babbage is composed of three main parts or components. No, there's the Jacquard's loom, which stores the input and stores the program. There's the mill. The mill is the processor, okay, and the store, which is the memory. Okay. Before that, let me show you because the problem with this, no, the problem with Charles Babbage invention is he was really not able to assemble it physically. Do you follow? Hindi talaga niya na-assemble physically because technology at that time was so crude that the parts cannot be just easily obtained. Okay? So hindi basta-basta ma-obtain. So this is in the London Museum, no? Currently, this is the original device, which is the small scale. Okay? Bagal, no? My internet is going slow. Okay? Anyway, ito na lang. Hirap, no? Ito sana. I hope you can have a clearer view. Ayaw pa. You can have a clearer view somewhere. Ito na lang. Yeah, I think this is clearer. This is the engine of Charles Babbage. No? Actually, this is only the mill. A partial implementation, a small-scale implementation. Bakit ayaw? Bakit ano? Okay. So, hanggang dito na lang, no? It's not that clear, no? Earlier this morning, it's clearer. So this is the this is the partial implementation created by Charles Babbage himself before he died or before he passed away in 1871. Okay, so naiwan pa. There's a legacy. There's a legacy that he passed on. This device is now in the London Historical Museum. Na? So nandito na ito. You can see this is made of rotating gears, and this is a small scale version because there are only 25 gears. No, there are only 25 levers. No? The original levers. No, the original design is supposed to be 50. Okay, but from the picture, from the image, you can see the different columns. No, so for example, this is the first set of gears. No, the first set of gears, and each gear can have the symbol 0 to 9. No? This first set of gears is the prime ingress axis. The second set of gears is the ingress axis 1. Okay. The third set of gears is the ingress axis 2. Okay. The next is the egress axis and the last set of gears is the egress axis 2. Okay. So this is the mill, which is supposed to be the central processing unit of Charles Babbage computer. So we do not have the Jacquard's loom and the store. Okay, if you were to program a computer like this, no, nowadays, you have to be very extra careful because, you know, there's a crank. Oh, this manually run, and you could easily cut a finger, no, if you make a mistake. Okay, luckily we don't have computers anymore like that, no? Okay, so that's the Jacquard, that's the analytical engine, and we know it has the Jacquard's loom, the mill, and the store. Now here's the program which I've shown you last meeting, no? I've shown you this last meeting. You can download this worksheet from Dagler. What it does is compute the fourth factorial. You know what the fourth factorial is already, right? So here it is how it is organized. No? The Jacquard's loom, which is the input device, actually stores the program sequentially. Okay, we can generalize the process by saying each step is composed of two steps. No, each process is composed of two steps. No, like the first step is to compute the partial product, so we do a times. The second step is to compute the next multiplier, so we do a minus. Okay, do you follow? So our store is organized in such a way that we use three variables. No, in 000 we use the next multiplier. Okay, in 001 we store the decrement, and in 002 we store the partial product. It's like a worksheet in Excel, no, or a RAM where there are addresses. No, so 000 is the column number. 001 and 002 are the column numbers. Okay, they follow. So remember that in the cards design, there are three types of cards: number cards, operation cards, and variable cards. No? A number card is like an assignment statement. It stores a value to the store. It assigns a value to the store. No? And an operation card tells that there's going to be a mathematical operation, either times, no, divide, plus, minus. And then a variable card is a card which transfers value from the mill to the store, or the mill or the store to the mill. No, if you transfer from the store to the mill, we issue a card called load, so L. If you transfer a value from the mill to the store, the card is S. The variable card is S. Do you follow? Okay, that's what we have. So let's run this formally now. So this is a fourth factorial program which starts with 4, not with 1. Okay. So N004 means 000 is assigned a value of 4. N0011 means 001 is assigned a value of 1. N0021 means 002 is assigned a value of 1. Do you follow, everyone? Recorded na ba tayo? Yes. Okay. So what we do first is to compute the partial product. So we do that by loading the multiplier, which is the degree, the first partial product. No, we do that by loading the partial product and the multiplier. So the initial product is 1, the first multiplier is 4. They come from 002, this is the 1, no? And 4 from 000. So 1 times 4 equals 4, so egress becomes 4. And we store the value 4 to the partial product, which is 4. No? What's the second step? Anyone? We compute the next multiplier. So then the current multiplier is 4, so we compute the next, which is 4 minus 1, it becomes 3. And we update the next multiplier to become 3. And we repeat the process, which means we multiply again. Okay? Sorry, no. I'm sorry. Sorry, I'm not supposed to have this, no? Anyway, never mind. Okay. So that's what we have. 4 times 1 equals 4 minus 1, which it becomes 3, which is the next multiplier. And then we repeat the first partial product, the next partial product is 4, the next multiplier is 3, 4 times 3 equals 12. So we will have 4 times 3 equals 12, which is now the next partial product. Okay. We repeat the whole process and then until we reach 1. Okay. And then the last final product is 4. You have done this before, no? So what we do is we print, then we issue a bell to wake up the sleeping operator, and we do a halt. A halt is like an exit. Okay, did you follow? Okay, everyone? Okay, okay. Any questions so far? No? Now, let's go to the documentation, no, of the analytical engine. Okay. There are two more cards. They are called combinational cards. It's a combination because it's actually it starts with C, no? But actually it's a branch and control card. Mabagal talaga. Okay, you have to wait a while. Anyway, there are two commands, CB and CF. CB means count backwards and CF means count forward. Let's read the documentation, no? Ito na lang. So ito, no? Can you see that? CF. CF means a combinational card. Tells the card reader of the card's loom to move forward or backward. CF means move forward if the run-up lever has been set. What do you mean when you say run-up lever? The run-up lever is the last result, which is usually the result that is stored in the egress axis. Do you follow? The last result, no, of multiplication, division, and whatever. No? And then CF and CB will succeed if the run-up lever is set. What do you mean by set? Set and reset are jargons in the binary language, right? Now, are you aware of that? No? When we say set, in binary we say 1. And we say reset, it's 0. But the analytical engine, being a decimal computer, when we say set, we mean non-zero. When we say reset, we mean 0. So when we say the run-up lever has been set, it means that it stores a value that is not 0. Do you follow?
Asan
Okay?
siya nag-store niyan, sir? Sa egress axis?
Sa egress. Because usually, the last result is in the egress axis.
So, for example, maglagay ka ng CF, then may value sa egress axis, doon siya
Yes.
mag-process.
Now, whether it's going to move forward or backward will depend on the egress axis, which means if it's set, it will move either forward or backward. Do you follow? Okay. To illustrate this point, no, let me show you the factorial program which uses a loop. Okay. Do you follow? Repetition ito. This is a trace of that program, no? My CF. The good thing about with repetition is you will have a shorter code and you can use it for a lot more purposes. Okay, like our previous program will only compute the 4th factorial. If you're going to compute for the 5th factorial, you will have to upgrade the code. Do you follow? Unlike when we are doing a loop, we just have to change the parameters of the loop. For example, here, no, N0014 means we are going to compute the 4th factorial. If you are going to compute the 5th, you just change the 4 to the 5. It just repeats because this repeats 4 times. And then when you say N0015, it computes the 5th factorial. N00110, the 10th factorial. Without you having to change the code itself. Do you follow? Diba? So that's why repetitions are very useful in any programming language. Now, this sample program, this is also found in the Stanford reference. I have updated it. No? I've made changes so that it will be easier to trace. No? That's why the uh, pro the analytical engine program needs repetition so that it can perform a lot more operations without having to change code. Do you follow? No? So anyway, let's trace this, okay? Find out how CF and CB works. So this is the same code, no? What I'm trying to do is uh, use 0002 to store the partial product. Next increment is in 001, the next multiplier, and the constant decrement of 1 in ST002. You can interchange it with whatever you want. No? So the process is still the same. The first step is to compute the partial product. The next process is to compute the next multiplier. But we will come on different passes depending on the status of the run-up lever. If the run-up lever If the line lever is already reset, we will stop. If it's a set, we will repeat. Do you follow? Do you follow? So we have N0014, so the first partial product, 1. And then we have 004, which is the next multiplier, and 0021, which is the decrement. So likewise, no, in the old program, when we say times, 000 is 1. It's clear here, no, the first partial product. 001 is 4. So we do a times, this becomes 4. No? And we store the next partial product to see here. No? So this becomes the next partial product is 4. You follow? Okay. So nothing new. Still the same. Now the next is we compute the next increment. Okay. The next multiplier. The current multiplier is 4. So L001, this is 4. We minus the decrement of 1. So this becomes 3. And we store the next multiplier to 001. So the next multiplier becomes 3. Do you follow? Now here's the question. We have CB8. What do you mean by CB? Move backwards or count backwards, right? How many steps will it count backwards? Huh, everyone? 8.
8
1, 2,
steps.
3, 4, 5, 6. Ulitin natin, ha? 1, 2, 3, 4, 5, 6, 7, 8. So hanggang dito siya, it will go back here. Do you follow? It will repeat this process. But it will repeat this process only when the run-up lever is set. What is the status of the run-up lever? Set or reset? Reset.
Set, sir.
Set, because it's a 3. No? In binary jargon, it's just a jargon. No? When we say set, non-zero or 1. When we say reset, it's a 0. The run-up lever is currently a set. So therefore, what will we do? Shall we move forward or backward? We will move backwards. So we will not proceed to these times, but we will go backward to this. Okay. So to make it clearer, no, I do not want to change the values here because these are historical values. I have repeated the code here, but they are the same code. But now we are on the second pass, no. But it's still the same code. This time we are on the second pass, and we will have different values, no. Our partial product is 4. That's our latest partial product. Our next multiplier is 3. It's here, no? It's 3. And our decrement is still 1. You follow? This is the second pass, which means this is the second repetition. It will compute for the next partial product by computing 4 times 3. Do you follow? Okay. Any questions so far? Pass number 2 tayo. Kasi nga, move backwards 8 times. That's why we are doing this, because we are supposed to move backwards. So what is LL00? It is 4. 001 is 3. So times will become 12, and we will store it as the next partial product at 00. So this is now 12. We're done with the first step. The second step is to compute for the next multiplier. Okay, so we do a minus from L001, which is 3, and L002, which is 1. So the next multiplier is 2, and we will store it at 001. Nandito, no? 2. Okay? So we're done with the second step. The next is a CB8. Do you follow? So what does CB means? Count backwards or move backwards, no? But what will we do? Shall we move backwards or move forward? Depending on the value of the run-up lever. Okay? Is it set or the egress axis? What is the value of the egress axis? Is it set or reset?
Set circuit 2
Set,
ang
sir.
egress.
Set kasi 2, it's a non-zero. So therefore, we will go back again. So we will come into the third repetition.
Ay sir, may question ako ba?
Yes.
Yung regarding good sa pass 2, i-write talaga namin yung lahat or parang gina-illustrate mo lang ang process?
I'm illustrating the process, but you will also have to write it yourself now when you trace a program. Okay? Because when you write a program, for example, the analytical engine, you have to check its correctness, right? Whether it computes
Sir.
properly. To do that, you will have to trace, no?
Ay, okay. So, i-write pa rin siya, pero yung process talaga sa analytical engine, kaya di na siya i-write.
Yeah, the actual program, I'm just trying to trace how it works. No?
Okay.
But depending on the question, no? Later, no, in the question, if you're asked to trace the program, you will have to fill up the values.
For example, sir, sa sheet 4, good, i-trace namin yung buong
Yes,
process
you
or
have
like,
to trace, no, in order to check. Anyway, there are only 3, di ba? You have
yes,
read
sir.
the assignment already?
Yes po.
Okay, anyway, I'm going to explain the assignment again, okay? Pagkatapos nito.
Okay, sir.
Okay. So after this, I will explain the assignment, okay? So dito tayo sa CB8. So obviously, we are going to go back into a third pass. So nandito naman tayo sa third pass. And then what's the value? The partial product is 12, the next multiplier is 2, the decrement is 1. Okay, so the partial product is 12, the next multiplier is 2, and the partial product is 1. Okay? So we do a times. L00 is 12, L001 is 2, and 12 times 2 is 24, and we store it to L00. So this now becomes 24. The next partial product is 24. We're done with the first step. The second step is to compute the decrement, or rather the multiplier. So we'll have minus of L001, which is 2, minus 1. So this becomes 1. And we store it to the 001. So this now becomes 1. Okay? Do you follow? Do you follow? Everyone?
Yes, sir.
Okay. Now, we have another CB8. What will we do? Forward or backward? Backwards. Still backwards because this is not 0 yet. Okay? So therefore, we'll have to go into a fourth step, fourth pass. No? In the fourth pass, our partial product is 24. Our next multiplier is 1, and our decrement is 1. Okay? We repeat the same process. 0, 0 is 24. Okay? 0, 0, 1 is 1. So 24 times 1 is 24. Okay? Do you follow? And we store it in 0, 0, 0. Okay, we're done. The second step is compute the next multiplier. So the previous multiplier from 0, 0, 1 is 1. The decrement is 1. The result is 0. Okay, 1 minus 1 is 0. And we store it to 1. This becomes 0. Okay, the next is a CB8. What is the run-up lever? Set or reset? Anyone?
Reset,
sir.
sir. Kay 0 na.
So shall we move backward or forward? Forward na tayo ngayon. Right? Forward na tayo. We are going to do a time so that we can set up the egress axis. We'll explain why is that. No? First, we times L002. See, L002 is 1. And L00 is 24, which is the final product. So the value of the egress axis is 4. Why are we doing that? Because we are going to issue a print. A P means print. Because we will output the value. We don't have a monitor. Okay? But the print will print to the last card that is present on the card loom. It will print 24 to tell the result, to show the result to the user. Do you follow? And it will do a bell because unlike nowadays, no, you have the screen which shows the status of your program. You can animate your program. In those days, they don't have an output device. They have a bell to tell the programmer who must have been sleeping already to wake up and find out the result. Do you follow? And then we have an H, which means hot or exit in C++. Do you follow? Any questions so far?
Sir, may instance ba na CF ang gamitin mo sa program?
Yes, especially if there's an if then else. For example, you are going to compute the grade of a score and then find out if it's passing or failing. Do you follow? Maybe gagawin ko yan, no? I'll show you a program. So in an if then else, you have to move forward. Skip, no? If it's passing, you say passing. If it's failing, you say failing. Okay? So in an if then else, CF is useful. In a repetition, a CB is useful. Do you follow?
Yes, sir.
I'll try to make a program, no? A simple program which computes the grade of a score and then determines whether it's passing or not. Okay? I'm not ready to show you that now, no? But I'll come up with that next meeting, no? Gagawin ko yan sa Excel. Okay? Kaya ba natin yon? Let's try to find out, no? Parang kaya, no? Later na lang. I don't want it to waste time, no? It's wasteful if you just do it by trial by error. I'd like to make a working program so that we can discuss. We will not waste time discussing, no? Okay, basta CF is in an if then else, no? You must, if you have done programming before, no? There are times when you have to use an if statement. That's the use of a CF. Okay, and a CB is used for repetition. Okay. So I prefer to do it next meeting, no? Para wala masyadong ano. Hindi tayo trial by error. Okay? So this worksheet can be downloaded in Dagler. Okay, we have without loop and with loop. Any questions? Now, let me show you other examples, no? The meters to feet.
Sir, pwede mag-ask?
Yes.
When storing, sir, sa ST000 mag-start or nakadepende sa kung saan mo i-store?
Where the vacant ano? Basta store it on a vacant ano. When you say N ba o L or S?
S po.
Like this S here, this is used to store the partial product, right? The
Yes,
partial
sir.
product is 4 and our designated column for the partial product is 0, 0. Right? Like a
Okay, sir.
variable. Okay? This is like the variable name. This is used to store the variable. So ang variable natin dito is 0, 0, 0. Because unlike in a programming language where you have variable names, here we have addresses. Diba? So address 0, 0, 0 is our variable for the partial product. You get my point? So if you compute a partial product, you store the value in 0, 0, 0. If you compute for a multiplier, you store the value in 0, 0, 1. It depends on which column do you use in order to store a particular variable. Do you get my point?
May question ako, sir.
Yes.
Di ba nag-try ako naglagay ng number sa N00, N001, tas N002? Possible ba na mag-save ako sa ST003?
Yes. Pwede. As long as where you designate your ano. You can use any column you like to designate a variable. For example, nothing will stop me if I'm going to use 003 instead of 000. In fact, when you see here, no, 00 in this version is used to store the partial product. But in our original version, the partial product is in 002. Do you follow? In our original version, the next multiplier is in 00. But in the second version, our next multiplier is in 001. You can designate any column to store whatever you want to store, as long as you are consistent. Do you follow? It's possible. You can use 5, 6, no? As long as you are consistent. That, for example, 001 is your next multiplier. Do you follow? Because when you're writing programs, dito we cannot figure it out, no? But these are like variables. in a computer program. But since we don't have variable names, we don't have variable declarations. That's always true, no? In the early computers, you will really have to use memory addresses. Addresses in memory that are used to store values for variables. I hope it answers, no? Do you follow? No? I hope it answers the question, no? Programming is an art, no? It's stylistic. It depends on your style. So you can use any variable, you can use any column. No? It doesn't mean that you're restricted to 000, 001, and 002. As long as it's vacant. As long as it does not overlap a different variable. For example, you cannot store the value 4 to 000 here because it's not the next multiplier. Here, 4 is assigned because this is the next partial product. Do you follow? You get my point? So logically, you really have to use your logic. No? Sequence programming is an art. You have to understand the logic of a program before you are able to build it. No? I hope it answers. No? You are free to use any part in memory. So anyway, let us proceed. No? I have other examples like a simpler example. No? Meters to feet. Ito. Meters to feet. How do you compute meters to feet? 1 meter is 3.28 feet. Do you follow? So in the store, we designate the following values. 000 stores the meters. Okay? We don't have 1 anymore, so we can delete this. No? Okay? And 001 stores the multiplier, which is 3.28. 002 stores our final result. Do you follow? Or this is the feet equivalent. Okay? So likewise, no, it doesn't matter. We are going to use meters here and feet here, multiplier here. Whether you interchange the values of the variables, it doesn't really matter. Or you use 003 for meters, you use 004 for feet, 005 for your multiplier. It doesn't matter as long as it produces the correct result. Do you follow? No? Okay. So the multiplier to convert meters to feet, you will have to multiply meters by 3.28. So in here, if you have the value that we convert is 4. So we apply N0004. Okay, if you wanted 5, you can use 5. No? And then we have N001 3.28. We need to store it in the program. And then the application is, the multiplication is you multiply the meters by 3.28. So the meters is in 000. So we have L000 and we have L001, which is 3.28. The result is 13.12. And we store it in ST002 because we designate the result to be ST002. We do a print so that the result is printed on the last card, and we do a bell and issue a bell and a hole. Okay? Any questions? So any questions? No? So it's a matter of what do you want to choose as the column for which variable. Okay, it doesn't matter whether you don't have to follow this. No? Okay, there are many ways to skin a cat, as there are many ways to write a program. Okay, so another example is the Fahrenheit to Celsius. Okay, Fahrenheit to Celsius. How do you compute Celsius, Fahrenheit to Celsius? These are measurement of temperatures, no? Naka-image kasi tayo. Let's just search again. So here is the formula. Subtract 32 from Fahrenheit times 5/9. It gives you Celsius. Okay? We follow? So in this case, okay, we use 00 to store our Fahrenheit value. Ito na lang, 004 na lang, okay? Kasi 00, yeah, 004. Hindi tayo mahirapan. Okay. Whatever it is, no? Okay, you follow? So 00 is our Fahrenheit value, and initial subtrahend is in 001, and our multiplier, which is 5, in 002, and our divisor, which is 9, in 003. Our result is in 004. Do you follow? So we end 001, 132, and end 001, 32. 32 is the value we want to convert, okay, from Fahrenheit to Celsius. N035 dito, N039 nandito. The first thing to do is to subtract 32 from degrees Fahrenheit. So we minus L00, which is the Fahrenheit, and 32, which is our first value. Okay. We have 100. We can store this back to 001. We don't need 32 anymore. Do you follow? So to save on space, we will just save it here. And then whatever the result is, we multiply by 5. So it's in 001, L001, we get 100, and we get 5 from L002, and we multiply, we have 500. We can also multiply store the result in 001 because it's no longer used, no, to save on space. And then we divide 500 from ST001 by 9 from ST003, and the result we store in ST004, and then we print, we issue a bell, and then we hold. Okay?
Ay, sir, may question ako.
Yes.
Necessary pa ba na i-save siya sa S004?
Not necessarily, no? As long as you have it in the egress.
Oh, okay.
Okay? Na i-print. Because it's printed anyway, it's print to card. Okay? Okay? Any other question? Any other question? So, I'll explain the assignment, okay? Let me explain the assignment. This is due on Monday. If you have read it already, due on Monday. Why Monday? Because I will discuss it already on Monday on my other class, and I don't want the solutions exposed, okay? Due on Monday, and we will discuss it on Tuesday. Bagal pa rin, may problema pa rin ng Degler. You have to wait because I have no other, hindi ko nalagay sa ibang ano eh. Okay? Now, are you all familiar with passing assignments in Moodle? Everyone? You know how to pass? Because you are going to save the assignment in an Excel sheet and then upload it to Degler. Are you familiar with this? I presume you are, no? Let me turn to another mode, another role. Problema nito, mabagal. You have to, you really have to wait. Wala tayong magawa. Tanduyan. Okay. Who else is late? Who else did come late while we're waiting? Correcto. Intise. Okay. While we are waiting, no, for Dagler. Ayan. Wala pa rin. Okay. So it's really very slow. Bagal. Sana na-open ko before, no? But anyway, you're supposed to write a program that computes first the sum and then Fahrenheit to Celsius and then the average. Buti na lang ano. Tapos na. The average of the first three numbers. Mawagal pa rin. Okay. Ito. To pass, no? You just click this. And then you add a submission. Okay. And then if you have a file, okay, if you have a file, for example, somewhere in your folder, you just drag the file from here. I-drag mo lang dyan. Okay. When it's done. Okay. And then you click Save Changes. For example, mag-pass ka, i-drag mo lang dyan. Okay? You just have to do that. Now, you write a program to compute the sum of the first four numbers. Numbers 1, 2, 3, and 4. So the expected is 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. No? Without a loop for the analytical engine and give a trace using Excel sheets and save it to sheet 1. Do you follow? It's like the fourth factorial, but this time we use plus instead of times. Paraiso is late. Any questions now? Okay, so this is the sum of the first four numbers. And then you write the reverse of Fahrenheit to Celsius. Convert Celsius to Fahrenheit. That's the formula there. F is equals to C times 9 over 5 plus 32. Okay. And then write a program to compute the average of the first three numbers, 1, 2, and 3. Okay, 1 plus 2 plus 3, whatever the average is. Okay, so compute the average of the first three numbers without loop for the analytical engine and give a trace using Excel sheet. So ibig sabihin you have to trace the way I did. Do you follow? No? So i-trace talaga and save to sheet 3. Now, for number 2, you don't have to give a trace, no? Simple. No, you're required to give a trace, no? Sorry, all of them, no? Okay, any questions? First three numbers without a loop. If you know how to compute the fourth factorial, you know how to compute the average. Okay? If you know how to compute the sum, you could also compute the average. Okay? Any questions? And then you write a program to compute the average with a loop this time of the same set of numbers and give a trace using Excel sheets and save it to sheet 4. And then when you pass, you rename your file as xr1 underscore followed by your surname, first name, and middle initials. For example, I can name my assignment xr1 underscore Heralde John Roy A. You follow? That XLSX. Okay? Any questions? Okay. Before you drag it there. Okay? Any questions? Bago me drag doon. So that's your assignment. Okay? You can just follow my example. Anyway, you don't have to start from scratch, no? This is very similar to the fourth factorial program. So pwede you can, to an extent, you can do a copy and paste and do a little modification. Okay? Any questions so far? No? So I expect that on Monday. Now let's go to the next topic, which is the descendants of Babbage engines. What happened after Charles Babbage? No? What happened after the analytical engine? Uh, incidentally, no, uh, before no, but incidentally nothing happened. But before Babbage, I'm sorry, Charles Babbage passed away in 1871. Okay, he built a small scale assembly. He assembled a small scale engine to represent the mill. No, only a portion. That's why it was never built fully. But he was able to build the mill. He cannot complete because there's no technology to build a store. Okay, there's a jacquard loom to build the cards, but the store cannot be built because there's not enough technology to build the store. No? So in 1909, no, the inventor, amazed by Babbage's invention, tried to assemble the analytical engine. Okay, his name is Percy Edwin Ludgate from Ireland. Okay, from Ireland. But like Charles Babbage, he was not able to build the design. However, like the analytical engine, it is decimal, it is mechanical, and let's say this true. It's mechanical and it uses a different type of memory called state rods. Ito kasing ano is a physical state of wheels and axis. Do you follow? Okay. Nothing happened until before World War II, where in Germany, no, an inventor, mathematician, and physicist named Konrad Zuse. Konrad Zuse is very popular. No? By 1939, he invented a mechanical computer patterned after uh, the analytical engine. But this time, it doesn't use the decimal number. It uses binary floating point numbers. Okay, so binary na ito, hindi decimal. And the programming was done using tapes or films, no? Film stocks, 35 millimeter tapes. Okay? However, it's not Turing complete. What do we mean by Turing complete? Also by about the same time, no, 1930s, Alan Turing, an English mathematician, okay, uh, developed a theory to determine whether a machine is complete or is finitely complete or not. What do you mean by finitely complete? All the states of the machine can be modeled, are known. When you say a machine is Turing complete or finite, Turing finite, we mean that all the states are known and the behavior of the machine can fully be predicted. Okay? So a Turing complete machine is like a computer program which has no bugs. Do you follow? No errors. It's like a perfect machine. Do you follow? Now, the analytical engine was considered to be Turing finite, Turing complete, which means it can really be built into an actual machine. Do you follow? Ludgate's analytical engine was also considered Turing complete. Okay? Zeus 1, Zeus Z1 is not Turing complete, which means there can be bugs. Okay? In 1939 also at about the same phase, no? The same period, no? Bomb was invented in Poland. It's also an electromechanical. Now, by the way, Z1 is considered to be the first, okay, the first generation computer. Okay, 1939. Meron ding bomb in Poland. Let's look at that, no? Ito. This is a wartime computer used for encryption, no? Because during the war, no, messages are encrypted. Okay, messages to soldiers in the front are encrypted. So there it is, no. It was pirated by the British from the Poles, kasi Poles was a Nazi, before 1939 hindi pa sila Nazi. So it was later used in Great Britain in 1943. It's not programmable, no. Cipher input. It's not Turing complete, and it uses the memory technology used by Konrad Zuse. By 1940, in Germany, Konrad Zuse also developed a second version of Z. It's Z1. This time it's electromechanical, including the memory. No? However, it's not Turing complete. Do you follow? So by 1941, at about the start, the war has already started. Konrad Zuse invented Z3, okay, which is also binary floating point, okay, using tapes, but it's not. It's already Turing complete in principle, which means it was not implemented physically. It was only in design. By 1942, uh, in the US, no, in the US, uh, uh, where is this? I think this is in Penn State by to. Iowa State University, no. Two scientists, no, Vincent Atanasoff and Clifford Berry. They are, teachers, no, sa Iowa State University. John Vincent Atanasoff. They invented the ABC computer, the ABC machine. It's not a computer, no. What's the purpose? It is used for linear systems, no, using punch cards. But this is not programmable and it's not considered to be a computer. However, it's a binary machine and it's electronic. And the good thing, okay, the legacy of the ABC computer is it's the first computer that uses capacitive memory, which is the same technology that we're using in our RAM devices nowadays, no? Capacitors ang ginagamit. But during those days, no, they are using vacuum tube capacitors, no? So let's look at that, no? So, okay. So meron ng capacitors, no, for memory. Where the capacitors are, we don't know. Okay? Do you follow? No, ito yung the Atanasoff Berry computer. It's not considered to be a computer, but it was distinct because it was the first device that uses capacitors as memory, which is the same technology that we are using until today. Okay, so when you are asked, what is the first computer using capacitive memory? It's ABC. Atanasoff Berry computer. Okay? Now, in the UK, by 1943, they developed Colossus Mark I. Colossus Mark I was a wartime computer. No? It's a wartime computer which is used to decrypt Enigma machine encryptions, because Germany during the war were using Enigma machines. Okay? Mga Enigma machines ito. What do? Before messages are sent into the front line, they will encode, or they will encrypt the messages so that if they are intercepted, the recipient may not be able to understand, no? Okay, the message. On the other hand, being the enemy of the Nazis, no, the British used a computer called Colossus I, whose main purpose was to decrypt messages encrypted by Enigma machines. No, we have no information about the Enigma machines because most of them were destroyed by the Germans before the World War II. So ito yung Colossus, oh. Do you follow? No, it is not a general purpose computer, but it's patterned like it's a binary computer. It's electronic. However, it's not Turing complete. Okay, It uses vacuum tubes, no, for memory. Okay, thermionic vacuum tubes for memory. Now after that, after the war, no, the Mark IBM invented, or rather, uh, assembled a computer for Harvard. It's called Mark I. It's different from Colossus because Colossus is binary and IBM Mark I is decimal. It is actually an implementation of Charles Babbage's design. Do you follow? It's made of mechanical relays. It's just like transistors, but this time mechanical transistors. No. So here's the no. It's unfortunately it's considered to be Turing incomplete. So hindi siya Turing complete. So here's the Harvard Mark I. Okay. Now Harvard Mark I became famous because when IBM tested this in Harvard, one day they were wondering because Mark I stopped operating functionally. So nag-dysfunction siya. And when they disassembled and find out what happened, they found out that a moth, no, a moth, you know what a moth is? Small butterfly, no? Was caught in between the gears, the mechanical gears of the Mark I. And that's why it stopped working. And they called it the bug. So nowadays when you say a bug, it's an error in a program. But originally it was a moth caught in between the gears of the Mark I. So it's now a new jargon. No? It's another jargon when you say a bug. A bug in a program is a defect. It's borrowed after the Mark I moth. Okay? Where was the bug coined? In the Mark I in 1944. Okay? So by 1945, about the end of the war, no, Konrad Zuse introduced a new version of the Zeus, no, of the Z, which is Z4. It is binary floating point, electromechanical, and punch card controlled, and it uses mechanical relays, and it's now Turing complete. Do you follow? And it is, okay, ano bang sinabi dito? This is an program, ano na eh. No, it's not a stored program concept. No, but this is the first commercial. No, the first commercial computer is the Z4. Okay, which means it's the first digital computer, binary being binary, which was sold in the market. How much it was sold, we don't know. So this is the Zeus Z4, okay, which is a digital computer, okay, invented by Conrad Zuse and was first sold commercially. No, the first commercial computer is Zeus Z4. No? Now by 1946, okay, Penn State University, no, developed crude implementation of, or actually released a crude implementation of Charles Babbage analytical engine. It's an electronic version, okay, but it's still decimal, so it's like the analytical engine. It's called ENIAC. ENIAC means electronic numerical integrator and calculator. Okay, it uses vacuum tube triodes for memory. Okay, it's Turing complete. It's like the analytical engine, however, it's electronic. No? So ENIAC was mostly programmed by women. Why? Because it was developed during the war and most men are in the war. So here's a picture of ENIAC. No? Do you follow? We will study this. No? We will study this particular computer. No? We may not program it because it's very complex, but we will mention a very important a novelty that is in ENIAC. Okay. Like there's a novelty in the ano in ABC, right? The capacitive memory, which is still in use today. There's a novelty in ENIAC. There's a novelty in the analytical engine. Okay? Do you follow? By 1948, no? Okay. In Manchester, England, okay, the English introduced, okay, a digital computer. Is it digital? Yes, a digital computer, no? Called Manchester Baby. It was invented by Frederick Williams, Tom Kilborn, and Geoff Tothill. Now, in Manchester, England, no? Ito yung Manchester Baby. Okay, it's like also a predecessor of the of course Charles Babbage engine, but this time this is a binary computer. This is an electronic computer, and it uses cathode ray tubes. It's Turing complete, and it is a binary program with the first keyboard. Do you follow? It's an electronic stored program concept because by 1945, the stored program concept was already developed in the US, no, by John von Neumann. He's a very important figure, no, John von Neumann. Even more important than Charles Babbage, I think, no, who designed the concept of electronic stored program. What do we mean by stored program concept? Because in Babbage's design, the program starts in the input device, no? Starts in the input device. In the stored program concept, the program runs in memory, not in the input device. Okay? Do you follow? That's what we mean by electronic stored program concept. And Manchester Baby is the first computer with a keyboard. Do you follow? Ang ganda, no? So, for the first time, we have a keyboard. In 1948, that's called Manchester Baby. It's ABC. So, meron na siyang keyboard. Where the keyboard is, we don't know. So, it's still in a museum, no? I think in London Museum, no? It has a control logic. Meron siyang storage. I think this is tape, no? Tape storage, most probably. Wherever the keyboard is, we don't know. No? Basta keyboard na siya. However, there's no information regarding whether it has a monitor or not. But for sure, we will encounter the first computer with a monitor later. No? Do you follow? Okay. Any questions so far? No? So, what is the first computer with a keyboard? Manchester, UK. The first electronic stored program computer? Manchester Baby. No? Okay. Do you follow? So, we will include this in our exam, no? Kasasali ito even in the summative test. All these things. Okay? So, that's up for today. We will introduce a new topic next meeting, no? For the moment, we do not have enough time for a new topic. Okay? Paraiso is late. Have I recorded that already? Yes. Anybody? Anybody else? Dagmil, are you there? Espinosa? Guiñez? Gutierrez? Iwata? Milyabe? Igaw? Pulido? Rica? Okay. I think that's all. So I will upload the video no, in YouTube and make a shortcut in Diggler. Okay. Any other questions? Do you have any questions? So remember your assignment is due on Monday. Okay. What's the date on Monday? 19 of July. Okay?
Ay, sir, may question ako about sa assignment ba?
Yes.
Yung sa sheet 2, good sa pag-convert sa Celsius to Fahrenheit ata yun. Mag-give lang kami ng any number in Celsius.
Yes. Use any number.
Okay. Sige, yun lang po.
Yes. The assignment is due at 12 noon. Okay? 12 noon, no? Okay?
Sir, pero okay lang 0 Celsius.
Come again?
Yung like yes is ko lang.
0 Celsius.
Ano
32.
po, sir?
What is the equivalent of 0 Celsius?
32 Fahrenheit po.
Dapat 32. Pag in-input mo 0, dapat 32 yung lalabas.
Okay, sir.
Okay? But if it computes a number other than 32, Well, that's wrong, no? Okay.
Okay, sir. Okay, sir.
Any other question? Okay. So we'll cut our session short. Okay. Today. Anyway, we only
Thank you,
have
sir.
about 10 minutes. So thank you very much. Thanks for coming. Now,
Thank you, sir.
Salamat, sir.
Well, sir.
see you next
Thank you,
week.
sir. Bye,
There will
sir.
be more people by next
Thank
week.
you, sir.
Thank you. Ang daming absent ngayon. Okay. Thank you.